On any given day, a certain machine has either no malfunction or exactly one malfunction. The probability of malfunction on any given day is 0.4. Machine malfunctions on different days are independent. Calculate the probability the machine has its third malfunction on the fifth day. Given that the machine has had has not had three malfunctions in the first 3 days. So let's understand this last statement first. Given that the machine has not had three malfunctions in the first 3 days. So at first sight, it seems as if we are saying that the first 3 days were all non-malfunction days. No, that's not what we are saying. We are saying that in the first 3 days, we have not had three malfunctions, which means we could have had 0, 1, or 2 malfunctions. So that's what this last part is saying. So now consider this statement, probability that the machine has third malfunction on the fifth day. So this is negative binomial. So if n is the number of days it takes for the third malfunction to occur, then n has a negative binomial distribution, which says that the probability of needing n trials to get r successes is given by this formula. P is the probability of success in each trial. So we are calling a malfunction as a success in this case. So n is 5 because we're talking about the third malfunction on the fifth day. So n is a number of days for the third malfunction. So n is 5, r is 3 because we're looking for the third malfunction, third success. And then probability of success in each trial is 0.4. That was the probability of a malfunction on the day. So substituting these, we get f of 5 equals 0.13824. So f of 5 is the probability that it takes 5 days to get 3 malfunctions. But that's not our answer because the question was probability that the machine has its third malfunction on the fifth day given. So we also have this given condition given that the machine has not had three malfunctions in the first 3 days. So now three malfunctions in the first 3 days will be 0.4 times 0.4 times 0.4 because malfunction on the first day and on the second day and on the third day. So that's 0.064. And so not three malfunctions in the first 3 days will be the complement of three malfunctions in the first 3 days. So it'd be 1 minus 0.064 equals 0.936. And we are asked this one, the probability of the third malfunction on the fifth day, given that not three malfunctions have happened on the first 3 days. So that by our basic given formula will be third malfunction on the fifth day and not three malfunctions in the first 3 days divided by probability not three malfunctions in the first 3 days. So we already know the denominator, that's the 0.936. So now the question is, we have this part, three malfunctions in the first 3 days, but the numerator is saying three malfunctions in the first 3 days and not three malfunctions on third malfunction on the fifth day and not three malfunctions in the first 3 days. So now let's try to understand if this given condition even has any effect on this probability that we are being asked. So not three malfunctions on the first 3 days means obviously that we have 0 or 1 or 2 malfunctions in the first 3 days. And if you think about it, it has to be like this, because if we had instead of 0, 1, or 2, if we had three malfunctions in the first 3 days, remember that's the only option. Either we will have 0 or 1 or 2 or 3 malfunctions in the first 3 days. So we are given that there are only 0, 1, or 2. And that has to be the case because if there were 3, then the third malfunction, if there were 3 in the first 3 days, then the third malfunction has already taken place on the third day. And there's no way we would have the third malfunction on the fifth day. So therefore, this condition that we are given that the that there are 0, 1, or 2 malfunctions in the first 3 days, it's an obvious condition without which the question doesn't even make any sense. So it's very similar. Let me give you another example to illustrate this. So let's say we are saying that the probability of the first rainfall of the year happening on January 10, given that there has been no rain on January 1 through 9. So did we even, does it even make any difference whether we are given that condition or not? Because, so what I mean is that if you say first rainfall on January 10 and no rainfall on January 1 through 9, so you can easily see that obviously first rainfall on January 10 will mean that there has been no rainfall on January 1 through 9. So that didn't even have to be said in that part. So in the same way, we have from what we have explained here, since this condition has to be there, it's an automatic condition for the probability that we are talking about. So whether we say third MF on the 5th day and not 3 MF on the first 3 days, or we simply say third MF on the 5th day, it's the same thing, because that automatically requires third MF on the 5th day automatically requires that you should not have 3 MF on the first 3 days, as I explained. So therefore, this numerator, the and part can just be omitted. So this and this is the same as just the third MF on the 5th day, and that we already have is 0.064. So now we are all set. Third MF on the 5th day, given not 3 MF on first 3 days, would just be the third MF on the 5th day, 0.1384 divided by the given, just 0.936. So that's 0.148. That was choice C.